Other same thing.
Other switch. The layer 3 switch, the other part. That's easy for high availability.
Right. This one, sir. This one, sir. This one. Right. Oh, this one. One is for the high availability, active standby. So.
And we have seen some stuff like VPC.
Yeah, VPCs will be like from the firewall will be connected with the switch over this VPC. The links will be VPC. There will be two links going, and we will bundle the links. That is called the VPC.
No, perhaps it was something to do with heartbeat, I guess. Heartbeating. So it tells the
connectivity will also be VPC. I'm sorry. Yes.
Yeah, VPC deals with the heartbeating.
Yes.
Just the other part that I'm alive. Only you fail. If you fail, I will take over. Something like this.
Okay.
As far as
we are configuring this for high availability.
It doesn't say anything with the second firewall.
Second firewall, sorry?
You said it doesn't. VPC does VPC deal with the second firewall or the
VPC switch level.
Switch level. So that's a switch level.
Okay.
Firewall we have two links. Firewall we will have two links. This is not a VPC concept. Over here, one link will be for the state traffic. Another link will be for the failover traffic. Actually.
Okay.
So these the heartbeat and everything is monitored by using these two links.
Actually, firewall
For the firewall,
the high availability in different way.
Okay.
Firewall high availability is a different.
High availability in this case is being dealt by the firewall.
No, what firewall?
Every equipment there is high availability. For the router there is two router. For the switch there is two switch. For the firewall there is two firewall.
Both will be active. I mean, both will be powered on. Automatic failover will take.
In case of firewall, actually, the stateful failover is also required because if you cannot transfer the states, you are connected to some website. So since the firewall is down, so that connection table also need to be transferred to the failover. So the stateful failover is required.
But these were separate two physical devices.
Yeah, these were two physical separate devices. Over here, there are virtual devices.
Okay.
Inside one of them, each one of them. Here are actually one switch will act as two switch, core switch and aggregation switch, core switch and aggregation switch. So if we talk about virtual context, we have got four switches. One core here, one aggregation here, one aggregation here. So 1, 2, 3, 4. Something like that.
What do you actually mean by aggregation? Because we are more than familiar of this kind of thing.
Alright,
Access distribution core. But aggregation is something is new to us. What does it really mean?
You can actually put aggregation in terms of distribution. I mean, it's a data center access network. I mean, aggregation, the term I have picked from, I don't know if you know about this overlay transport virtualization, the OTV, the one that we will be applying here. So over there's a concept. One they call the core layer, and another one they call the aggregation layer. In the aggregation layer, they map all the VLANs and all the access networks there. But in the aggregate, at the same layer, you cannot do the routing. There's a requirement, there's a dependency to run that functionality over the transport network. So for that, you need to have a separate box or a separate device to handle the routing functionality.
And you mean handling the IPs.
Yeah, exactly. IPs has to be handled either in some other box, or you break the box in two contexts, and then you do it.
Okay. So you need to do virtualization in the switches.
Exactly. This is how the tender document has required and asked for, and we have actually freezed our design and licenses and everything accordingly. Everything according to the requirement of the tender.
And what are those two links between these two? Yeah, lower links. Between these two, these two switches. Yeah.
There's a 10 gigabit links, 10 G links, just for the to maintain the failover heartbeat, and also to configure the HSRP. The traffic.
Heartbeat is the upper one, I guess.
Heartbeat is the upper one, yeah. It is shown logically. If you go through this two links or one.
Those were physicals.
Those were physical.
Okay, let's get the next slide.
Maybe like this. Over here is the same diagram, but it is just the the we have actually pointed out the port addresses here. I mean the port numbers but unfortunately we couldn't see it properly. We have supplied it as a document. If required, we will reprint this one and we will resupply it. Then you can show it. This is more of a low-level design concept, actually. Because we are mapping the ports, we'll connect this one to that one, this one to that one. But the topology remains the same.
No, here you need DMZ switching here. The previous has no have DMZ switch.
So this one?
Right. But again, can you tell me what's the function of the DMZ switch?
This one's a DMZ switch.
DMZ DMZ. It's server switch and DMZ.
Oh, DMZ. Sir, the DMZ network in short, in the broader form of DMZ is demilitarized zone.
Oh.
Actually, all the internet-facing servers who are prone to attacks and who are vulnerable are placed at the demilitarized zone, and it's a separate zone. And these servers and those servers that lie in the data center, they may not have internet access at all to secure them more. So this is actually a security concept. So it will be a separate zone, and the connectivity from the firewall, I mean the logical connectivity from the firewall would be different for them. They will have the internet functionality. They will be able to go to the internet. The proxy, the webs, and the other internet-facing server will be based at the DMZ.
Publicly accessible servers.
Publicly accessible servers, sir. The email, external email clients, they will be here.
Still, they will be having the physical connection to the
Yeah.
non-DMZ.
Exactly. This is actually the blade chassis, right?
So is there
one of the
any firewall between the DMZ and non-DMZ?
Yeah.
There is internal firewall. That will be
Internal
configured in
firewall.
internal firewall.
Our firewall, our firewall.
In
No
switch
physical,
as well.
no physical device there, but there's supposed to be some limiting of access.
Yeah.
Whom do you trust? Who can access?
Yeah. In
So
the
that will be
firewall, we
configured
have
in the
three
firewall.
zones. In the firewall, we have three zones. One is the outside, one is the inside, and another one is the DMZ. Outside is untrusted, inside is trusted, and DMZ is semi-trusted, you can say. Or you can also say it untrusted. Because you'll be going to
What do you want to know? How do you separate the DMZ and non-DMZ? Is there any firewall in between?
there's a firewall.
They will be connected physically, of course.
Yes.
They have to be connected.
Yes.
But how do you ensure from DMZ to non-DMZ it's been secured?
Actually, from DMZ to non-DMZ, the traffic will traverse through firewall, must traverse through firewall.
Understand? That's the networking.
The physical part.
That's not in the system admin. That's not in the system admin, because once you have passed through the networking, once you have passed through the layer 2 switch, it's now in the scope of this system admin. So how do you ensure because DMZ zone is being exposed to the internet.
Internet, yes.
So how do you make sure that DMZ and non-DMZ they have been secure? The connection has been secure.
There will be ports, separate physical port at the firewall that will be dedicated for the DMZ, dedicated for the outside and dedicated for the inside traffic. So that physical port will be connected to the inside blade chassis switch in turn, and at the load balancer, and from the load balancer it will come to the separate VLAN of the switch, and from that separate VLAN the servers will be segregated.
Your VLANs and that's a different things.
The policy will
Nothing to
probably
do
be
with
different.
securities, I guess. VLANs you're segregating any part, and it could be any department, any section. And load balancing, you balancing on the load. If the load is excess, you give it the load to some other device or some alternative device, to make it more available. Not available, I would say some additional device. But it's a security feature. I'm discussing. I want to know about the security feature from DMZ to non-DMZ. How it's been ensured.
Sir, from DMZ to the non-DMZ, do you mean from DMZ to the inside?
From
From DMZ to the inside. So there will be routing configured.
Routing is in the network part, sir.
Sir, actually there is in security concept, outside is security 0, inside is security 100. And DMZ middle of something like you can configure 40, you can configure something. It depends on.
Still, so at the DMZ, outside people can access.
Outside
you are allowing
DMZ, yeah.
You are almost allowing anybody to access your web server.
Yes.
Isn't it?
Yes, sure.
To access
But
your web
I need to configure which service I can allow access. I need to configure, explicitly configure which I am going to allow
Only through
access
IP,
from
nothing else.
IP
If
and also
it is-
service.
If it is to the public,
Not
anybody
just
can
IP,
access
also
to the
service.
IP.
Say I am just hosting only the web server. So I will allow only port 80 and port 443, HTTP and HTTPS.
What about
Nothing
open
else.
ports?
Sorry?
That will
Port
close.
880K.
That
What
will
about
close.
open ports? What
That
about
all
open
No, I will not keep it open. For
You have
DMZ,
to
I will
ensure
not keep
all
it open.
ports are closed. How do you ensure that?
By default, all ports are closed. From outside to inside, outside to DMZ, ports are closed. I need to explicitly allow the ports. So that is a security feature. So from inside to outside, all ports are open by default. From inside to outside. But from outside to inside or DMZ to inside, not all ports are open. I need to allow the ports. So from DMZ to inside, I need to allow
That
those
means
ports.
if anyone is allowed from inside,
Yeah,
right?
Yeah.
I need to allow. From outside to
If
inside or
anyone is allowed
inside is the most
from
secure.
inside.
Secure. Inside is 100 secure, 100% secure.
880, which they allow. What about the other ports? How do you make sure they all the ports are closed?
Like ACM.
Now we can
Like ACM. You have to.
You have to do the
we
ACL.
can also check.
Can you ensure that all the ports have been closed?
We will check.
It's
Yeah,
a
later
part of the
after.
hardening procedure. We understand.
Definitely.
You
But
have
we
to
also
make
propose
sure
the
that all the ports. Right.
understand your concern.
It's a big issue.
Yeah, definitely,
Because if any port if it remains open, it will be exposed to the outside environment.
We understand your concern, and that's why later in our tender document we propose a security testing. So after implementing the security policy, we will test whether the port is open or
And also
illegitimate
we-
port is open and illegitimate
Yeah,
port
you
is
have to
closed.
show the process as well, because if you go away, I'll be able to take up the matter whichever ports are open.
No, they will definitely show you the process, all the process.
Okay, that's fine.
Okay, then, next. Alright, this is only the DC part. We have shown it separately. And still things are the same. You see we have two internet firewalls, two core routers, two core firewall, the core and the aggregation switch. And from this part of the network, we'll have switch to switch connectivity with the BRNet. So this is just shown separately. Things are all the same. And I just one part that is below this section,
video
another network which is the storage network. So the storage network will be covered in a separate seminar afterwards. I'm not in this seminar. This is seems to explain the entire topology. This is just shown, but we will discuss it at the upcoming seminar. We will give the dates for
continue
right now.
করতে পারবো
Is it all for today?
No, sir.
No, no, no.
Okay.